very soon. 22 nano is being installed النهارده. ففي ناس كتيرة بتتكلم عن نانو تكنولوجي generically. اوكي؟ وناس بتتكلم على quantum dots وكلام عجيب كده يعني انا personally يعني I reviewed for NSF many times and I'm very scared. لأن واحد بيقول لي quantum dot هعملها 1 micrometer quantum dot. This guy is not aware that we are today doing 22 nanometer transistor and it works. It's production. By the time he makes it production, we'll be talking 10 nanometers. So the only working nanotechnology in electronics is the existent CMOS technology. It's nano. It's nano by any definition, right? When you talk 22 nanometers transistor, it's a nanotechnology. So that's why I put nano in my center, since everyone who's not nano claiming he's nano to make money these days. It's a sexy word, right? So I decided, why not make it nano-electronics, at least I'm not lying. And the challenge with nano-electronics is that it's going, when you go down to this size and so on, the number of transistors is so large, there's design complexity, there's all this issue with the physical level and so on. So that's why, that explains to you why the number of, the frequency is not scaling anymore. That's the number of cores is going up and they're much easier than scaling the frequency. هو ده الترند بتاع النانو تكنولوجي. مش هنبطل ان احنا نشتغل physical level issues. It's still huge. بس حكاية ان many core was a way انك تقدر at least to survive a few years. So I guess with that, this is the digital side, which is my expertise. I'll let Dr. Ismail take over the analog and RF part.
I just learned about this like 2 days ago, so I came and I'm sorry that I am not properly dressed for talking to you, but he told me that this is a conference completely organized by the students. So I was very interested to come here and talk to you about that, and I'm really glad to see all of you here. And it looks like you have a very nice organization here, so I'm very, very, very happy to see that. I'm also happy, and I hope that you enjoyed the lectures by Dr. Sanad and Dr. Yehea Ismail. It actually gave me some sense of optimism that both of them had very successful careers in the US and then came back to share their knowledge with people here. So it's a very interesting and optimistic way, or something that makes me very optimistic about the future of technology in Egypt. And I think we'll talk about that perhaps in the panel more this evening. Okay, I have a lot of slides, and I wanted to talk to you about something that I've been doing for a long time, which is designing radios for wireless communication. So if you look at any mobile phone, you will see the antenna. As Dr. Sanad said, it's now inside the phone, and then after the antenna you have a radio part, which is basically RF part, and then you have a digital part. So basically I'm going to talk about the radio part, the RF part, radio frequency part. I was just wondering if you have a course here in RFIC in the curriculum. Is there such a course in RFIC? So there's no, okay. And most of the students here are electrical engineering, I understand, and computer engineering. There's no other like mechanical, mostly electrical engineering, right? Most of you are electrical engineers, right? Okay. Very quickly, basically, as Dr. Yehea Ismail mentioned, we are now designing radios in 65 nanometer and 45 nanometer technologies. So it's extremely very difficult to design a very complex radio in these type of technologies. And what happens in industry is that these radios usually take a long time to develop. And I'm going to talk about that very quickly. But what we would like to be able to do is to minimize the time it takes to design this radio. Make it faster so that you can reduce the cost of developing a product. Normally, in Intel, for example, when they did this in Trino, the wireless LAN radio, Wi-Fi, it takes about 40 years. It takes an army of engineers, maybe 100 engineers, to do the system definition, the design, the layout, the test, validation, the certification, and type approval. All these things take a significant amount of time. And the reason it takes the time is that RF design is like magic, is that you have to, in designing the circuit and the layout, and it takes many spins, many silicon spins. You do it in design one part of the radio, and then design the second part and the third part, and they work separately. But when you put them together, then you start to see problems in the performance. So that's basically what we have been looking at for many years. We have generated more than 45 PhDs looking into different aspects of designing radio chips. And now we're designing radios in SoC, like we put the radio and the digital, and some of the front-end parts in the system and package or a system on chip. So it's becoming very complex, and the testing part of it becomes extremely complex to test that. So one important aspect, you probably have noticed the phone used to be very big 10, 15 years ago, and then it became smaller and smaller. And basically that primarily is because the digital part of the phone is becoming smaller because of the scaling. But the radio part now is a challenge. How to make the radio part smaller? That's a big question. And in fact, as some of the speakers before mentioned, the mobile phone is becoming more of an entertainment center. So, you have the chipset for mobile phone itself, you have the Wi-Fi, Bluetooth, FM radio, MP3 player, GPS. You have so many different chipsets there, so many antennas. So in order to, and then when you go buy your next phone, you don't want to pay too much. You change your phone maybe every 2 years or every 2-3 years. So you want to keep the same price. You don't want to pay for it, but yet you want more services. So how do you reconcile what we call performance-price ratio? So you want to have a lot of performance, a lot of services, but you want to have the price very small. Okay, so that's another important challenge. And the challenge actually basically resides in the radio part of the system. Not much in the digital part of the system, but mostly in the RF part. And also in the front-end components, such as the antennas, the switches, the filters, duplexers, and all these things. So I'm just going to go through these things very quickly and then talk about how to make the radio design successful from the first time, what we call first pass radio. And that's basically our main niche in the company that we work on. We basically, very quickly, because we don't have so much time, we try to put in self-calibration, which is digital, to calibrate every aspect of the radio and make it work from the first time. And we also implement some smart methods for built-in self-test, so that the radio will test itself, test the performance itself, and then correct the performance automatically digitally. Okay, so that's the kind of the technology that was developed over many years by so many PhD students. So we'll talk more about, I'm going to skip many of these things because this talk was prepared for a much longer time. So I'm just going to focus about, I may just show you some chipset evolution for the mobile phone very quickly. And I also wanted to mention the fact that there is a big competition now between cellular and WiMAX, and the fact that this is being resolved by introducing an LTE, which is a new standard, and then go directly to the calibration thing. So I'm going to skip the generations, going from 2G to 3G, and I'm actually very pleased to see that in Egypt 3G is becoming everywhere. That's not actually the case in the US yet. In the US you don't have 3G services everywhere, like what you have here. So, which allows you, of course, to do high-speed multimedia, video streaming and things like that. Or you can go to it with WiMAX. Okay, so there's a competition about how to reach this high data rate. And of course, mobile phone companies were very nervous to see the internet now getting, I'm sure that everyone here uses Skype, for example. You have a good quality for service, you can do it. There is also something that came up in the US called a Magic Jack that you can put in your laptop, and then laptop becomes a phone. So there is a big, the big companies like Vodafone and British Telecom, Verizon,